So let's talk about now why we have to think about significant digits, why they're important to us. And they're important to us because of the lab, okay? It really helps us reflect the uncertainty in measurements, knowing how many digits are significant. So here's an example. So here we have a burette, okay? And you're going to be learning how to use these virtually. I would love it if you learned how to use them in person, but c'est la vie. So here's a little picture of what this burette looks like. And it's got this little thing at the bottom with another little valve that you can open and close and allow liquid to drip out the bottom here, right? The liquid is going to go down. All of these lines that you see right here are called graduations. So for example, in a graduated cylinder, it has those little lines. A burette, a beaker, etc. Anything with those little lines, we call them graduations. And so when reading, in this case, a burette, this is different than reading a graduated cylinder, but reading a burette, because the liquid is dispensed down, you read the burette going down. So the first thing that's important to note is counting the graduations and what each value is worth. So here, let's see, here this big line is the 40, and then here this big line is the 41. So if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 graduations between the 40 and the 41. So that means each one of these is 0.1 milliliters. All right? And so when I'm reading this down, this is not a 42.1, 2, 3, 4, 5, 6, 7, 8. It's not 42.8. Rather, it's 41.12. Okay? And so now this little line right here, I'm going to draw my best possible attempt. That's what we call the meniscus. Meniscus, okay? And that's what we have to estimate. We have to estimate where that is. So the first thing that we do is write down all of the digits that we're certain of. So we know, for example, that it's 41 points. And then look, here's the 41.0, 41.0, 41.1. And this line right here is 41.2. And this line right here is 41.1. So we know our result is going to be somewhere between the 0.1 and the 0.2. It's your job as the experimentalist to estimate what it is to the best of your ability. Okay? So if I were looking at this, where the meniscus is, I would say it's maybe closer to the 41.2 mark. So I might guess maybe 41.7. That's my guess, right? But there's no right or wrong answer because it's what we're estimating. So sorry, that's 41. Let me write that again. Not 41.7, but it's 41.17. Okay? So, and you'll learn this in lab as you go. But if our device has graduations every 0.1 milliliters, you're going to estimate the uncertain digit right here is one digit past the digit that you have a graduation for. So in this burette, you have graduations every 0.1 milliliters. That means you're going to have to estimate to the best of your ability the 100th place, the 0.01. I guessed 41.7. So let's say 5 people look at it and these are their results. Okay? Maybe one person thought 41.15, 41.18, etc. Well, we average all these together and we get 41.16, and we recognize that that 6 is the uncertain digit. And here we have 4 significant digits in this number, and that last one is always uncertain. All the same, the more digits we have, the more precise our number is. So that's why these burettes are very precise at delivering liquid. And I'm going to talk about what that means in the next slide. Okay? So precision versus accuracy. Okay. And again, instead of giving you a definition, let's learn by example. Which of the following is precise but not accurate? Okay. Well, we can talk about all of that for all of them. So A, you can see maybe this looks like how I would play darts after a couple of beers. So A is not accurate at all because we didn't hit the bullseye. And it's not precise. Excuse me, I got either a frog in my throat or recording 3 lectures in a row might be too much. We'll see. So, and it's not precise because these arrows are all over the place, right? If we try to average this result, the uncertainty would be large. But now if we look at B, B is not accurate because you didn't hit the bullseye. But it is precise because every single arrow went about in the same direction. Okay. And finally, C is both accurate and precise. So yeah, good job. Because not only do they all hit the bullseye, or they hit the bullseye and all of them hit the bullseye. So that's accurate and precise. Okay? And so hopefully you'll be able to explore this. Well, I should say hopefully. You will explore this a lot more in your virtual labs, this precision and accuracy and how we apply significant figures in the lab. So this will not be the last time you see a burette, and on these virtual labs, you're going to be able to like zoom in and look at the meniscus and make an estimate the same way you would in person, the same way you would in an actual chemistry lab.